In geometry, you may have learned about trig ratios in the form of this mnemonic SO, KA, TOA, which stands for the SOH, the SO, first part, is sine, and if we're given a certain angle, let's call it theta, sine of theta is equal to O over H, or O stands for opposite over hypotenuse. So in terms of a triangle here, given that we have angle theta, this given angle here, the opposite side would be over here, which would be side BC. So sine of theta is equal to BC over the hypotenuse, right? So if you take a look at that, the hypotenuse in a right triangle is always going to be directly opposite the right angle, and so therefore that would be side BA. So sine of theta is equal to BC over BA. Likewise, if we take a look at the ka, so ka toa, ka stands for cosine, and so cosine of theta, if you look at angle theta again, it stands for A over H, and A represents the adjacent side, A for adjacent, and that's over the H, which is going to be, again, the hypotenuse being opposite the right angle. And the adjacent, if you know what adjacent, that just means next to. It's the angle, it's the side that's next to the given angle that you're looking at. In this particular case, cosine of theta is therefore going to be the adjacent side, which is CA, over the hypotenuse, which is BA. And then lastly, we take a look at TOA, which stands for tangent, and tangent of theta represents OA, which is opposite, over adjacent. And if you take a look at the sides of how we labeled them, opposite and adjacent, that would mean that tangent of theta is equal to BC over the adjacent, which is CA, like that. Okay, so let's take a look at the next example here. Draw an equilateral triangle with sides of 2x. I'm going to go ahead and label these sides as 2x, 2x, and 2x. Because it's equilateral, all three sides are equal to each other. Draw the altitude. So I'm just going to drop an altitude straight down. Altitudes are perpendicular to the base from its highest point. So there's the altitude. And label all side lengths and angles. Okay, well, if we know it's equilateral, I guess we can also determine that equilateral triangles, with a triangle being 180 degrees, means that each of these angles are 60 degrees. 60 degrees. And therefore, if this is 60 degrees, the altitude actually breaks it up in half, and therefore each of these are 30-degree angles here. Likewise, the altitude, because it's being dropped straight down the middle of the triangle, it therefore bisects our base of the triangle. And so if it has an original length of 2x, that must mean that each of these side lengths is going to be a length of x and x. It gets cut right down the middle. Now, if we just use the Pythagorean theorem, we can actually find what the altitude, or this side length of this particular triangle is. And the way we can do that is understanding that with the Pythagorean theorem, we kind of have like your A, your B, and like your C here. So if you think of a squared plus b squared equals c squared, and fill in the missing parts, what we have is x squared plus what we're trying to find, let's still call it b squared, is equal to 2x squared. 2x squared is the same thing as 4x squared overall, and then on the other side we still have x squared plus b squared, and therefore b squared is equal to, if you subtract x squared on both sides, right, you're going to get b squared is equal to 3x squared, and therefore if you take the square root, also keep in mind that because b is a length measurement, you actually cannot have the negative when you take a square root, and so therefore you still just get the square root of 3x squared, or in the end, what you when you simplify that, you just get x square root 3. So this side length is x square root 3. Okay, so taking a look at this triangle, what I want you to now do is focus on this 30, 60, 90 degree triangle with the measurements of x root 3, 2x, and x. I would then like you to go ahead and fill in the rest here. Number 3. What figure could you draw to find sine 45 and cosine 45 degrees? Well, if we're talking about 45 degree angles, very similar to how we had split a 60 degree angle in half and got 30 degrees, the way we can split an angle and get 45 degrees would actually to be drawing a square. In drawing a square, we have 4 right angles, and by splitting it in half, just like this, then the 90 degree angles get split in half, which means that these are each 45 degree angles. Also, if we're dealing with a square, then we know that each of the side lengths are all equal to each other. So we have x, 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 and x. And what we're looking for then is what is going to be the length of this hypotenuse. We want to find that. And so similarly, we can think about Pythagorean theorem again. We have a right triangle here. So we have x squared plus x squared is equal to c squared, and that's what our length is, the c. So we get 2x squared is equal to c squared, or c is equal to the square root of 2x squared, or simplifying that, you get that c is equal to x root 2. So this is the length of x root 2. Again, with these three measurements, given a 45, 45, 90-degree triangle, go ahead and find sine 45, cosine 45, and tangent 45.